In this lecture, you will be learning more on solving linear equations. We will learn and use the 4 steps for solving a linear equation, solve equations that have no solution or infinitely many solutions, solve equations with fractions and decimals as coefficients. Let's get started. We will follow these 4 rules to solve these linear equations. First, simplify each side separately, combining the like terms. Isolate the variable term on one side, then isolate the variable, and you can check the final answer if you want in the original equation. We will be taking 3 different types of linear equations here. The equations which has exactly one solution, no solution, and all real numbers or have infinitely many solutions. Here's our first example. Negative 3k minus 5k minus 6 plus 11 equals 2k minus 5. Obviously, you can see that we have same like terms on the one side, which I'm going to get combined. Let me get the pen here just to show you which terms are like terms. So here I have negative 3k and negative 5k, which are like, and I have negative 6 and positive 11, those are like. So I'm going to go ahead and combine them, and I will get negative 8k plus 5. Negative 3k minus negative 5k will give me negative 8k. Negative 6 plus 11 will be 5. That equals 2k minus 5. Now I have k on separate side of equation. I will try to eliminate one of the k's. In this case, I will get rid of the negative 8k by adding positive 8k to both the sides. And that way I can eliminate the negative 8k and the positive 8k. And I will end up having 5 equals 2k plus 8k, 10k minus 5. Now I will try to make 10k isolated, which means I need to get rid of the negative 5. Opposite of negative 5 will be positive 5. I will be adding positive 5 to both sides. This way I will get 10 equals 10k, because negative 5 and positive 5 here is going to get cancelled right there. This is going to get cancelled. So that's how I get 10 equals 10k. And here negative 8k and 8k was cancelled. So now we want k alone. So using a multiplicative property of equality, I'm going to divide both the sides by 10. And that should give me my k equals 1. So the final answer is k equals 1. In this lecture, I'm not checking, but if you want to check, you can put the k equals 1 in the original equation to make sure the both sides comes out to be same. Let's look at another example. 7 times p minus 2 plus p equals 2p plus 2, 2p plus 4. This one has a parenthesis, which means I'm going to use a distributive property. 7 times p, 7p. 7 times negative 2, which is negative 14, plus p equals 2p plus 4. Now I'm going to combine the like terms. So in this case, I'll combine the 7p and a p. Don't forget there is a 1 in the front. That will make that as 8p. So that's how I get 8p minus 14 equals 2p plus 4. Once again, I have to eliminate either 8p or 2p because they're on the separate side of an equation. I decide that I'll get rid of the 2p. So by doing this, the 2p's will get canceled, and I end up having 6p minus 14 equals 4. So this 2p right there will get canceled, become 0. Now I want 6p by itself. So to get rid of the negative 14, I'm going to add 14 to both the sides. So I can get rid of the 14s, and this should give me 6p equals 18. Now I want p alone, so dividing both the sides by 6. That should give me p equals 3 is my final answer. Let's try another example. Now that we know that every time we have a parenthesis, we'll be using a distributive property. Let's distribute that. 3 times m here gave me 3m. 3 times 5 gave me 15. I brought down the negative 1. I brought down the 2m. And then the right side, 5 times m, 5m. And then 5 times 2 gave me 10. Now I'm going to combine the like terms, 3m and 2m. And then I'm going to combine 15 minus 1. That's how I get 5m plus 14 equals 5m plus 10. So it doesn't matter here which m I will eliminate because both are exactly the same m, 5m. So when I try to eliminate one, both gets eliminated. So 5m minus 5m on one side and the 5m minus 5m on the other side, both become 0. So this is an unusual situation we haven't seen in the previous example. The first thing you notice is that the letter is gone. And the second thing I notice is that 14 equals 10 is not true, which means it's a false statement. So anytime when you get a false statement and you see that the variable is gone, you will write your answer to be no solution, meaning there is no such a number for m that I can replace on both the sides of equation that will make it same. It's not possible. So the first type, we saw exactly the same answer. This is the second type, but there's no solution possible. Let's look at this example. Once again, we will start distributive property. So that will give me 4 minus 6r right there. I have 2 times 2, 4. And then 2 minus negative 3r, negative 6r. And then the other side, 5 times 1, 5. 5 times negative r, negative 5r. Now, right side, I have to combine the r's right there, and I'm going to combine the numbers up there. So that should give me 4 minus 6r equals 4 minus 6r. It doesn't matter which number or letter I can get rid of first. I will try here getting rid of the 4 first. In this case, I will end up having negative 6r equals negative 6r. Both 4 got cancelled. Now if I try to add the 6r, then both will be cancelled again. So in this case, I got 0 equals 0. So even if somebody chose to do the negative 6r first, in that case, you will end up having 4 equals 4. So in either case, whether 4 equals 4 or 0 equals 0, the similarity is that the statement is true. 4 equals 4 is true, 0 equals 0 is true, the variable is gone. So the answer I'm going to write is all real numbers are the solution, which is the same thing as infinitely many solution. Meaning this equation doesn't have 1 or 2 or 3 answers, it has infinite many. Because any number you replace the r by on both the sides, that always will come out to be same. So this was our third type, all real numbers. Now let's move on to the equations involving the fractions. So equations which involving the fractions, what you can do if you don't see anywhere the denominator, you can always put like underneath a 1 if you wanted to. And then you can find the LCD for 4, 3, 1, and 6. Meaning the number which is in 4 times table, 3 times table, 1 times table, and 6 times table, that number is 12. So what I would do here is I would multiply the denominator by a number so that I have all of them change into 12. So what I would do here is the first one, if you think, for example, what should I multiply 4 to get 12? My answer will be 3. So if I do that in the bottom, I must do that on the top. The second one, I'm going to multiply by 4. 4 times 3 is 12. So the same thing I'll do on the top as well. Similarly, 1 times what is 12, which is 12 right there. And therefore, on the top, I must multiply by 12. And the last one, 6 times what will give me 12? The answer is 2. So the same thing I'll do on the top. So this is the step you will see in my next step. This is what I have done. So I multiply by the number such a way so I get 12 in the bottom. So now that if I go ahead and multiply them, I will get 3 times 3, 9 over 12x, minus 4 times 1, 4 over 12x, plus 12 times 5, 60 over 12 times 1, 12, equals 10 over 12x. Once you see that the denominator is same, the shortcut that you can use is just eliminate the denominators. This technique, you can do it only with an equation, not with an expression. So once the denominator is same, you can just eliminate the denominator and now just write what you see on the top, which is 9x minus the 4x plus 60 equals 10x. Now this is an easier equation to solve. 9x minus 4x becomes 5x plus 60 equals 10x. We'll subtract the negative 5x on both the sides. The 5x will get eliminated on the left side right there. So we end up having 60 equals 5x. And then in the end, when you divide both the sides by 5, you will get x equals 12. So the whole purpose here with the fraction was to eliminate the denominator once they become same. And then the linear equation just becomes easier to solve. I'm going to show you one more example of the fractions with the parentheses, this time applying the same approach. Let's try another example. Here's another example. 1/7 times 3x plus 2 minus 1/5 times x plus 4 equals 2 over 1. Now, if you see that on the right side, I don't have any number. Obviously, you're going to put the 1 there. And now I'll find the LCD for 7, 5, and 1. So 7, 5, and 1, the LCD is 35. So I'm going to make everything 35 just like I did previously. So as you can see, I multiply the first term on the top and the bottom by 5, so I can get 35 on the bottom. The second term, I multiply the top and the bottom by 7, so I can get 35. And on my right side, I multiply both the top and the bottom by 35 to get 35 in the denominator. Let's go ahead and multiply here. And as you can see, we have 35 in all the three denominators. Now I can get rid of them because it's an equation. What you see on the top will be 5 times 3x plus 2 minus 7 times x plus 4 equals 70. We will use the distributive property now to get rid of the parenthesis. So I'm going to multiply 5 times 3x to get 15x, 5 plus 2 to get 10, negative 7x, negative 28 equals 70. Now we will combine the like terms. 15x and negative 7x are like, and positive 10 and a negative 28 are like. That will give us 8x minus 18 plus equals 70. To make 8x alone, I'm going to add 18 to both the sides of an equation. That way you can eliminate the negative 18 and positive 18. Getting 8x equals 88. Last step would be dividing both the sides by 8, and that should give you x equals 11. So this is an easier way of doing a linear equation involving a fraction. If needed, you can pause the video and watch the previous and this example again. I'm going to move on to the decimals now. Here's an example of a decimal. You can solve the decimal as the problem appears with just the regular linear equation, or you can first remove the decimals by multiplying by a certain number. So in this case, I have a 1 number after decimal. Here I have 2 numbers after decimal. Here I have 1 number after decimal. And here I have 1 number after decimal. So the highest number of times that I have numbers after decimal is 2. All the remaining are 1. So basically you pick the highest number, and that includes the 2 zeros, because I must multiply 15 by 100 to make a whole number. So all the sides, both the sides of the equation, you must multiply by 100, not the 10. Okay, so if all were 2 decimals, obviously it will be 100. But if you have a choice between the 1 decimal and 2 decimals, then you will go with the higher number. So if I have to multiply each of them by 100, then 0.3 is going to become 30 if I move this 1, 2 times. See that? And this is going to become 15x. This is going to become 20. And the last one also becomes 20x. So this is what you see. 30 times 30 plus 15x equals 20 times 30 plus 20x. This is after removing the decimal. Let's go ahead and multiply now. 30 times 30, 900 plus 15x, 20 times 30, 600 plus 20x. We will subtract now 15x from both the sides of an equation. And that will give us 900 equals 600 plus 5x. The 15x and the negative 15x would cancel right there. Once again, I want 5x to be alone. I'll get rid of the 600 by subtracting both the sides. You can get rid of the 600 right there, and you will end up having 300 equals 5x. X to be alone now, dividing both the sides by 5. The final answer will be x equals 120. You don't have to put the decimal back anywhere. This will be your final answer. Let's try one more decimal. 0.3 times x plus 15 plus 0.4 times x plus 25 equals 25. Now, here you have only one number after decimal and one number after decimal. So here we are multiplying by 10. Okay, when I say multiply by 10, both the sides of equation. So multiply each side by 10. Even though I don't have a decimal on the right side, I have to be consistent with that. So if I multiply by 10, I'm getting 3 times x plus 15 plus 4 times x plus 25 equals 25 times 10 equals 250. Now using additionability property, this is what you're going to get. 3 times x, 3x. 3 times 15, 45. 4 times x, 4x. 4 times 2500. Now we'll combine the like terms right there. 100 and 45. And we'll combine 3x and the 4x. So we will get 7x plus 145 equals 250. To get the 7x alone, I'm going to subtract the 145 from both the sides. This 145 is going to get 0, so you will end up having 7x equals 105. Dividing both the sides by 7 now to make x isolated, you're going to get x equals 15. If needed, you can see again this previous example and try without removing the decimal. You should still come up with the same answer.